Hello everyone, today we are going to go over the problem coin change for some blind 75 C++. And before we get started, just got to put our 4 questions over what we need to ask to help break down the question. So, what we need to do is the following. Got to figure out what our input is, what data structure / algorithm / technique to use, what to do with the data, and then what is our output. So, to be able to give a rundown on everything else, you are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Okay, so we have an array of coins and an integer representing amount. You can even look at the parameters up here and distinguish them. Return the fewest number of coins that you need to make up that amount. Okay, return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of the coins, return -1. Okay, you may assume that you have an infinite number of each kind of coin. Okay, so to be able to give a breakdown, so we have a series of coins with the amount being 11. What is the fewest combination that we can make to be able to get 11? And looks like we can do 3. So it's 5 nickels and a penny, which add up to 11. And if there was no combinations, we will add the 3. We return -1. And for coins with amount 0, we can output 0 because it is valid. Okay, makes sense. Valid, not valid, valid. Got it. Makes total sense over here. And given the fact that what we were doing, since we're searching for combinations, and we need to replicate a certain pattern, and we can have combinations coming from the front and behind, we're going to do dynamic programming, finding all the combinations from left and right to then replicate our desired behavior. And now, what do we need to do with the data? Now, I'm just going to give the steps. It's just 4 easy steps. This is why people love dynamic programming. It's easier to build up. Space complexity is efficient. Oof. Okay, so step 1. We need to first initialize our DP array with the size amount +1 to account for the combination, and fill it with amount +1 just in case of a 0. Actually, no, that would not be the case. Let's stick with this. And then we're gonna set DP of 0 immediately to 0 as the base case. Then we're gonna, for each coin in coins, we're gonna iterate over through our array from coin to amount and set the current element over through the array from coin to amount, and we're going to set the current element of here equal to the min of where we are at in our array with respect to where we are at minus the coin number we are at plus 1. So what we have for step 3 is that we're going to have DPI equal to the min of so what we are going to have for step 3 is that while we are looping through the core of our array, for every coin value we are iterating through our array, we're going to check to see if one of the coins is going to be less than the value or equal to the current amount of where we are at. And we are doing so by checking the coin so we can minimize the number of coins required, since we need the fewest amount, which would explain why we are subtracting from our current element all the way to the coin number as well. And finally, we'll return the array with the amount in mind. So to give a rundown, we're going to initialize into, we're going to have a vector int dp amount plus 1, amount plus 1. Then we're going to initialize as our base case, dp of 0 is equal to 0, and then step 3 we will have to iterate through our array, coin in coins, 3a, and then we're going to treat this like a regular one. However, since we're doing a combination, we need to start with where the coin is at, and I is going to be less than or equal to the amount, and it says we need the fewest combination, and then dp of I, we're going to have our min, since we are looking for the fewest combination of where we are currently at inside of our array, and storing all the values we have visited. We're going to also have coin number where we're at, and then this one here, so that way because it's going to be representing a scenario where we use the current coin to make a change, and we add 1 because we're using an additional coin, because since we were taking the minimum of the current value, we need to ensure and always hold the minimum number of coins needed, which would explain our plus 1. And then finally, we will be returning the amount if it's greater than the amount, or -1 if there is no amount. Oh, wrong side. There we go, passes all the test cases. And it works. Okay, so now just to give a rundown over a whole solution over what we have is that our target complexity for the following is going to be O of amount times n, where n is the number of coin types, and this can be for each coin, and we are calculating the exact value for all the amounts of what we've added up for the total. And the space complexity is going to be O relative to the amount, since we are using an array to store all of the elements that we have visited in our coins, and the amount of the coins is going to, the amount we need for our elements to be able to add up to the coin is going to vary because we need the fewest amount. So the bigger the amount, the more likely we're going to have to use more coins, which would explain our space complexity. So space complexity is O of amount and time complexity is O of amount times n, where n refers to the number of coins. So yeah, this was coin change on C++ Leetcode. Thanks again for taking time to watch this. If you found this helpful, like and subscribe. And if you have any questions, feel free to put them in the comment section. And as always, take care. Bye-bye.